You have just read the words of John Maynard Keynes. It is better to be roughly right than precisely wrong. This single sentence captures the ultimate tragedy and the ultimate triumph of econometrics. Look at the world around you. We have gathered our raw material, the data, but like base lead, it is scattered, chaotic, and seemingly without purpose. In our previous journey, we established that a perfect golden thread, the true population regression function, runs through this chaos, silently governing human behavior. But we are trapped in the cave. We cannot see it. We only hold a fragmented, unpredictable sample. Our task now is the most difficult in all of statistics: estimation. How do we draw the best possible line through these scattered shadows? If we simply guess, our line will be arbitrary. It will be precisely wrong. To find the truth hidden within the chaos, we must perform a mathematical transmutation. To extract the true golden parameters, we must apply the alchemical fire, a mathematical algorithm known as the method of ordinary least squares. But how does this fire actually work? Imagine drawing a line through your scattered data. Every time your estimated line misses a data point, it leaves behind a gap, an error known as a residual. Naturally, we want to draw our line so that the total sum of these errors is as small as humanly possible. You might ask, why not simply add up all the errors and minimize the total? Here is the trap. Because human behavior fluctuates, some data points sit above the line and some sit below. The positive misses and the negative misses would cancel each other out, giving us a sum of 0, even if our line was wildly inaccurate. To prevent this deception, the alchemical fire squares every single residual. Squaring achieves two brilliant things. First, it forces all errors to become positive, so they can never cancel out. Second, it acts as a merciless judge. By squaring the gaps, the algorithm punishes large, extreme outliers exponentially, and by mathematically minimizing the sum of these squared residuals, the fire forces our line to sit in the absolute, undeniable center of reality. But the fire alone is not enough. The transmutation will fail if the vessel itself is tainted. In econometrics, this vessel is the Classical Linear Regression Model. This model provides the strict, pristine assumptions required for our mathematics to hold true. These are the unbreakable laws of the Crucible. First, the parameters must be strictly linear. Second, the expected average value of the chaotic, unobservable disturbances must be exactly 0. Third, the variance of the errors must remain constant across all data points, a state of perfect balance known as homoscedasticity. And finally, the errors must never be correlated with one another. There must be no hidden patterns, no autocorrelation in the shadows. If the data violates even one of these sacred assumptions, the crucible cracks, and our resulting estimation will be corrupted. However, when the fire of ordinary least squares is applied, and the crucible of our assumptions is absolutely pure, a miracle of mathematics occurs. This miracle is mathematically proven by the legendary Gauss-Markov Theorem. The theorem guarantees that under the assumptions of the Classical Linear Regression Model, our estimators achieve the ultimate state of perfection. They become BLUE, Best Linear Unbiased Estimators. They are the best, meaning they possess the absolute minimum variance of any possible guess in the universe. They are linear, and they are unbiased, meaning that while they may fluctuate from sample to sample, on average, they will strike the exact, true population parameter. The chaotic lead of random data has been successfully transmuted into a golden, unbiased truth. We are no longer precisely wrong. We are roughly, perfectly right. Finally, as the smoke clears, the alchemist must ask how much of the raw lead actually turned into gold. We measure the success of our regression with a specific metric, known as R squared, the coefficient of determination. Imagine two overlapping circles in the dark. One circle represents the total variation in our dependent variable, the effect. The other circle represents the variation in our explanatory variable, the cause. As they move together, they overlap, and the greater the overlap, the more the cause successfully explains the effect. R² measures the exact percentage of that overlap. If R² is 0, the variables are entirely disconnected, and the spell has failed completely. If it is 1, we have explained 100% of the chaos.